some cool stuff with triangles today. I have an ordinary triangle here, and I have some starbursts. I actually have a whole bunch of starbursts. And we're going to look at the sides of this triangle. We're going to look at the starburst. So let's look at this starburst, or this triangle, and I'm going to put starbursts on the side, and I'm basically measuring this triangle in starbursts. So this starburst is, or this triangle is 3 starbursts on that side. And there's an important thing about this triangle. It's a right triangle. How do you know it's a right triangle? You know it's a right triangle because I told you it's a right triangle. It's the same as parallel lines, okay? It's not a right triangle unless I say so, or unless you can prove it. All right, so let's see how many starbursts are on this side. All right, so we have 4 starbursts on that side, 3 starbursts on that side, and let's look at this side over here. Kind of the slanty, slopey slide, right? Like if this was the slide, this is the part that you'd slide down. So there's 2, 3, 4, perfect, 5. 5 starbursts that way. All right, big deal. What does this do for us? Like, why do we even care? Well, let's play with it some more. I'm gonna have, so this 5 starbursts, 6 starbursts, 7 starbursts, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So I took 25 starbursts to fill that up. Okay, probably wondering what in the world Miss Barlow was doing. Let's maybe keep going a little bit here. All right, so I've got this down here. Let's see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, I need to get more starbursts. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. Huh. So I have 3 on this side, I have 4 on this side, I have 5 on that side. So that really wasn't that big of a deal. But when I make squares out of them, this is what I did. I made a square out of this one. I squared it, right? That's 3 times 3. That's 3 squared. And there's 4 times 4. There's 4 squared. And there's, when I squared them, this one plus this one is 25, right? So we have 9 plus 16. 9 plus 16 is 25. Over here we have 5 times 5. This is 5 squared, which is 25. These two added up equal this one. Well, that's kind of interesting. That's kind of cool, actually. When it was just the straight line, they didn't, right? 4 plus 3 is 7. That's 5. Like, who even cares? But when we square them, we have this relationship that this side squared plus this side squared is the slopey side squared. Now, the question is this true for all triangles? Is it just true for this triangle? Is it true for all right triangles? Like, what in the world is going on here? Well, let me tell you. Let's move some starbursts out of the way. And I taped this guy down so that he would not move. It's actually true for all right triangles. Let's talk about the anatomy of a right triangle. We have a right triangle here. Okay, here's our right angle. So let's say you are at the park. Here's Mrs. Barlow at the park. Hey guys, I'm at the park. And this is the slide. And this is the ladder, right? And this right here is the ground. And this part, I'm gonna do it in purple. This part right here, woohoo, is the part that we slide down, okay? Well, if you're gonna go up the ladder, that's one of the legs. And if you're gonna go across the ground, that's the other leg. And if you look at it, if I turn this around, I can kind of make a person here, right? Hey, there's Mrs. Barlow wearing kind of a funky dress. Well, no, those are my legs, right? Those are my legs. So this is a leg, and this is a leg. This has a very fancy name called a hypotenuse. How in the world do you remember that name? When you climb this ladder, you get really, really high up. And you're at the top of the ladder and you're like, oh crap, I have to use the bathroom when I'm at the top of the ladder. But along comes floating away a toilet on a cloud. Well, that's awfully awesome. You can use the high pot. You can make that high pot in use when you're on top of this slide. I don't know if that'll help you remember it, but it might. So the hypotenuse is the slidey part, and it's always the one across from the right angle. You've got the leg, they're both touching the right angle. This hypotenuse is not touching the right angle, okay? The hypotenuse is the special one. We're going to call it C, and we're going to call the legs A and B. And it doesn't matter which one we call A, and it doesn't matter which one we call B, but it does matter which one we call C. C is always the hypotenuse. Always, always, always the hypotenuse, okay? So there's this nifty thing. The nifty thing is called the Pythagorean, whoops, let's see if I can spell it right. Pythagorean Theorem. It was made by a man named Pythagoras. He's a Greek man. And he's Pythagoras, and he discovered and wrote down the Pythagorean theorem. And what it is that if you have a leg, and you have the length of the leg, and the length of the leg is A, and the length of the other leg is B. On our triangle that we did, they were 3 and 4. Now, if I just add 3 and 4, that equals 7, and the hypotenuse was 5, and they do not equal each other, and what in the world? But do you remember what happened when we squared them? When we squared them, then they equaled each other. 3 squared plus 4 squared did equal 5 squared. So if we have 3 squared, that's 9. 4 squared is 16. 5 squared is 25. Well, 9 plus 16 is 25. Does 25 equal 25? Well, of course it does. And it works. And it's happy. And we're happy because it works, right? And it works with all right triangles. So if I have a triangle like this, would it work? Well, clearly that is not a right triangle. So nope, it's not going to work on that one. It only works on triangles that are right triangles. Period and end of story. So let's do a couple. Let's do a couple of examples. I'm going to flip this paper over in safe paper. Those poor trees, I kill so many of them. So let's say I have a triangle and its legs are 3, 7, and C. Okay? 3, 7, and C. Which one do we want to be A and which one do we want to be B? I'm going to call 3A and 7B. Does it matter? No. But C is always C. Always, 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 always. The hypotenuse is C. Always the hypotenuse is C. So if I have A squared plus B squared equals C squared, A is 3, so 3 squared plus 7 squared equals C squared. Okay. So 3 squared is 9. 7 squared is 49 equals c squared. Well, 9 plus 49 is 58 equals c squared. Now, do I really want to know what c squared is? I do not. I don't want to know what c squared is. I want to know what c is. So how do I figure out what c is? Well, do you remember from our last assignment? If I want to know what c is, so remember 58 is c times c. What number times itself equals 58? Well, how do I figure that out? Well, I take the square root of 58, and the square root of c squared will give me c. Now, I don't have my calculator with me. I am at home, so I'm going to use my computer. So 58, the square root of 58 is, oh dear me, is 7.6157731058633908. First of all, is this a rational number? I mean, look at that. It goes on forever and ever and never ever repeats. So first of all, it is not rational. But do you need to write down all those many digits for your answer? No. We're going to round it to the nearest hundredths place. So I'm going to look at this guy. That's a 5. 5 is greater than or equal to 5. Obviously, it's equal to 5. So this guy gets rounded up to a 2. So it's 7.62 equals C. Boom. And I'm done. Let's do another one. Let's do another one. What if I have, I'm going to change colors so you can tell the difference between the problems. What if I have 8 squared? Well, I have a triangle. It's 8 on one side. It's a right triangle. How do I know it's a right triangle? Because I told you it's a right triangle. So I can either say this is a right triangle, or this little square in the corner means it's a right triangle. So it's 8 on one side. It's 11 on the other side, and we don't know what it is. We're going to call it C. Okay, we know that the Pythagorean theorem works for right triangles. So we know that 8 squared plus 11 squared equals c squared. Well, what's 8 squared? 8 squared is 64. What if you don't know in your head what 8 squared is? Use a calculator. It's totally fine. I don't even care. So 11 squared is 121. Again, I just know that one in my head, but not everybody does. Is c squared. Well, 64 plus 121 is 5. So it's 18. 185 equals c squared. So what does c equal? Well, what in the world is the square root of 185? This is not something I know in my head. So I'm going to pop it into my computer here and take the square root. This is c squared. I do not care what c squared is. I care what c is. So I will take the square root of c squared. So the square root of c squared is c. I will take the square root of 185 because I'm doing the same thing to both sides. So my equation will still be equal. So 185 square root is, ooh, it's a long one. I'm going to write this whole thing and then we're going to round it. 13.6014705087354. Does it go on longer than this? Yes. Does it go on forever? Actually, yes. Are we going to write down all the digits to forever? No. So we know that it's not rational, right? I'm not going to ask you these on these, but I'm going to remind you about rationality and irrationality probably for the rest of time. And we're going to round. We're going to round to the nearest hundredths place. So I'm going to look at this one. Is this one greater than or equal to 5? No, it is less than 5. So this one will just stay the same. So C equals 13.6. I could add the 0 if I really wanted to show that I know it to this precision. And there we have it. I'm going to do a couple more. What if I have a triangle like this? It's 2 on this side, it's 5 on this side, and it's C on that side. I don't know what C is. Well, it's a right triangle because they told us. 2 squared plus 5 squared equals C squared. Let's see. 2 squared is 4. 5 squared is 25. Oh, 2 squared is 4. Don't put the squared there. Okay, 4 plus 25 is 29 equals c squared. I do not have a clue what the square root of 29 is. I know it's going to be it's going to be in between 5 and 6. I know that. Because it's bigger than 25 and it's less than 36. Square root of 29 is 5.38516480713, blah, blah, blah. So c equals that. I'm going to look at this guy right here. This 5 is bigger than 5, or it is equal to 5. So this 8 gets rounded up to being 9 when I round it. So 5.39 equals c. Now I want to teach you guys about a does it make sense test on this Pythagorean theorem stuff. It's 5.39. If you look, 5.39, 5, 2. Which one's the biggest length? 5.39. The hypotenuse is the biggest. Let's look at this one. This one was 7.62. We have 7.62, we have 7, and we have 3. Which one was the biggest? The hypotenuse. Let's look at this one. We have 13.60. We have 13.60. We have 11. We have 8. Which one was the biggest? 13.6. This is your does it make sense test. You know you have done it right. Well, you have a little bit more of a reassurance you've done it right if you finish this and you find that the right answer, or that the hypotenuse is the longest length. The hypotenuse will always be longer than the legs. Now I'm going to go ahead and do a couple from your actual assignment. So let's do number 1 and number 2 from your actual assignment. So we have 3 squared plus 9 squared equals c squared. Okay, so these are the legs of the triangle. 3 squared, 9 squared, and then c is the hypotenuse. And we know it's the right triangle because they told us with the square. 3 squared is 9. 9 squared is 81. C squared. 9 plus 81 is 90. 90 equals c squared. Well, I know that c times c equals 90. So if I take the square root of 90, I'll find out what c equals. So c equals, I do not know what the square root of 90 is in my head. Do you guys know what the square root of 90 is? You are awesome if you do. C equals 9.4868. It's a big, long, irrational number that I'm not going to write the whole thing. So I'm going to look at this. It's bigger than 5, so this gets rounded up. So C equals 9.49. And I'm going to circle my answer so that poor Mrs. Barlow can find it on my paper. Okay, let's do number 2. And then I think that'll be all that we're going to do. All right, so we have the legs of the triangle are 2, and they're 8. We don't know the hypotenuse. So we know that a squared plus b squared equals c squared. A is 2. 2 squared plus 8b is 8. 8 squared equals c squared. Could I have had ab 8 and 2b b? Yeah, like 2 squared plus 8 squared is the same as 8 squared plus 2 squared. You can flip-flop those. You just cannot flip-flop the c. This one guy's alone on his side of the equation. You can't flip-flop him with the other guys. So 2 squared is 4. 8 squared is 64 equals c squared. 4 plus 64 is 68. Okay, so I know that c squared equals 68. So what does c equal? C equals, I don't know what the square root of 68 is. Let's calculator that. 8.2462 is a big, long, irrational number. This is a 6. It's greater than 5, so this gets rounded up. So C equals 8.25. And I circle it so poor Mrs. Barlow can find it. All right, there you have it. Good luck. Let me know if you have any questions. Your assignment isn't terribly long, and it's pretty straightforward. And have a good day. Bye.